I welcome you all for our lecture series on food technology. In today's lecture, let us make an attempt to know about nutrients. Introduction. Nutrition is the science of foods, the nutrients and other substances therein, their action, interaction and balance in relationship to health and disease. It includes the processes by which the organism ingests, digests, absorbs, transports and utilizes nutrients and disposes of their end products. In addition, nutrition is concerned with social, economic, cultural and psychological implications of food and eating. In short, nutrition science is the area of knowledge regarding the role of food in the maintenance of health. Food is anything that we consume and drink. Foods nourish, repair and helps to maintain health of our body. The major functions of food is life support function. In addition to that, foods satisfy hunger and create pleasure and happiness when we consume foods of our choice. The major functions of food are to support physiological function and maintain health by providing body building and regulatory functions. It also provides psychological satisfaction by relieving hunger. With these aspects, we shall study nutrients and their functions under the following subtopics. 1. Nutrients, its definition, essential nutrients. 2. Types of nutrients, macro and micronutrients. 3. Deficiency of nutrients and toxicity. 4. Manifestations of nutrients, underweight and overweight or obesity. 5. Energy and its requirements. 6. Units of energy. 7. Energy value of foods, RDA, BMR and BMI, and conclusion. First is nutrients. Nutrients, which are basically considered as organic materials in foods, help in nourishing the body. They are the chemical substances obtained from food and used in the body to provide energy to support growth, maintenance and repair of body tissues. They may also reduce the risk of degenerative diseases. Essential nutrient. An essential nutrient is a nutrient that the body cannot synthesize on its own and must be provided by the diet. These nutrients are necessary for the body to function properly. The 6 essential nutrients include carbohydrates, protein, fats, vitamins, minerals and water. 2. Types of nutrients. Nutrients are generally divided into macronutrients and micronutrients. Macronutrients constitute the bulk of the diet and are needed in large quantities and supply energy as well as essential nutrients needed for the growth, maintenance and activity. Carbohydrates, protein, fats, water are called as macronutrients. Micronutrients. Minerals and vitamins are called micronutrients as they are required to the body in small quantities. A. Carbohydrates. Carbohydrates are the main energy source for the brain. Without carbohydrates, the body cannot function properly. They are made of carbon, hydrogen and oxygen and are a major source of fuel for the body. 60% of the total energy requirements should come from carbohydrates. Dietary sources include fruits, breads and grains, starchy vegetables, legumes and sugars. B. Proteins. Proteins are the major structural component of cells and are responsible for the building and repair of body tissues. Protein is broken down into amino acids which are building blocks of the body. 9 of the 20 amino acids known as essential amino acids must be provided in the diet as they cannot be synthesized in the body. 10 to 35% of our daily calories should come from lean protein sources such as low-fat meat, dairy products and eggs. Among plant-based sources, grains, legumes provide protein to the diet. Fats. Fats are the concentrated sources of energy. They are the energy sources when consumed increases the absorption of fat-soluble vitamins A, D, E and K. 20% of the total energy intake should come from fats. Choose healthy options such as omega-3 rich foods like fish, walnuts and vegetable-based oils. Limit intake of saturated fats such as high-fat meats and full-fat dairy products. Other smart choices include nuts, seeds and avocado. Vitamins. They are a group of organic substances required in trace amounts for the normal metabolic functions, growth and maintenance of the body. Unlike carbohydrates, proteins and fats, vitamins are not an energy source, but they play crucial roles in extracting energy from these nutrients. They are divided into two groups, water-soluble and fat-soluble vitamins. Water-soluble vitamins or B-complex vitamins include thiamine B1, riboflavin B2, niacin B3, pyridoxine B6, folate, cyanocobalamin B12, pantothenic acid, biotin and vitamin C. Fat-soluble vitamins include vitamin A, D, E and K. Vitamins are found in a wide variety of food like fruits, vegetables, grains, legumes, dairy products, meats and fats. Minerals. Minerals are the inorganic elements which play significant roles in our body. They are often grouped as major minerals and trace minerals. A single mineral has several functions. Some minerals such as iodine are components of hormones and many other are components of enzyme or enzyme cofactors. Others serve a structural function. For example, calcium and phosphorus makes bone harder. Major minerals. The 7 major minerals are sodium, potassium, chloride, calcium, phosphorus, magnesium and sulfur. Trace minerals. Iron, zinc, selenium, iodine, copper, manganese, fluoride, chromium and molybdenum. Sources of minerals. Foods from both plants and animals are sources of minerals. They include rice bran, green leafy vegetables, fish and organ meats. Water. Water is an essential part of our body and constitute to about 45 to 75% of a person's body weight. It helps to maintain homeostasis in the body and transports nutrient to the cells. It carries food through our digestive system, transport nutrients to the cells and tissues and carries waste out of our body. Deficiency of nutrients. Nutritional deficiencies known as malnutrition are the result of our body not getting enough of the nutrient it needs. Children are more at risk for serious complications due to nutritional deficiencies than adults. Deficiencies can lead to a variety of health problems. Causes of nutritional deficiency includes inadequate ingestion, increased excretion, inadequate absorption, increased requirement, inadequate utilization and increased destruction. Any one or combination of these may result in nutritional deficiency. Toxicity of essential nutrients. One is iron toxicity. Iron may accumulate in the body because of iron therapy given in excessive amounts or for too long. Repeated blood transfusions, chronic alcoholism, overdose of iron. Iron overload can also result from an inherited iron overload disease called as hemochromatosis, a potentially fatal but easily treatable genetic disorder in which too much iron is absorbed. Next is fluorine toxicity. Excess fluorine can accumulate in teeth and bones causing fluorosis. Drinking water containing more than 10 ppm is a common cause. The earliest signs of fluorine toxicity are chalky white, irregularly distributed patches on the surface of the enamel. These patches become stained yellow or brown, producing a characteristic molted appearance. Next is manifestations of nutrients. As a consequence of dietary deficiency, several nutritional deficiencies with clinical manifestations and disabilities are encountered among different age groups, which is being shown on the figure. Protein energy malnutrition, PEM, which is common among preschool children. iron deficiency anemia in all age groups, particularly in women, children and pregnant women. Vitamin A deficiency in children, iodine deficiency, B complex deficiency, calcium deficiency, particularly in women. Undernutrition. Undernutrition is defined as the outcome of insufficient food intake and repeated infectious diseases. It includes being underweight for one's age, too short for one's age, stunted, too thin for one's height, that is wasted, and deficient in vitamins and minerals, that is micronutrient malnutrition. Underweight. It implies that the body weight of an individual is below the accepted average normal weight. The definition is usually made with reference to the body mass index, that is BMI. A BMI of under 18.5 is usually referred to as underweight. Causes? The causes of underweight are as diverse as those of overweight and are as follows: altered response to hunger, appetite, satiety and external factors, eating disorders, compulsive dieting, over-exercising, metabolic and hereditary factors, prolonged psychological and emotional stress, addiction to alcohol and drugs. Underweight can be a sign of underlying disease such as cancer. Illness can speed up metabolic rate, spoil the appetite or interfere with digestion. Correcting underweight helps improve the quality of life. Obesity and overweight. Overweight and obesity are defined as abnormal or excessive fat accumulation that may affect health. The fundamental cause of obesity and overweight is an energy imbalance between calories consumed and calories expended. Globally, there has been an increased intake of energy dense foods that are high in fat and an increase in physical inactivity due to the increasingly sedentary nature of many forms of work, changing modes of transportation and increasing urbanization. For adults, World Health Organization WHO defines overweight and obesity as follows. Overweight is a BMI greater than or equal to 25 and obesity is a BMI greater than or equal to 30. For children, age needs to be considered when defining overweight and obesity. For children under 5 years of age, overweight is a weight for height greater than 2 standard deviations above WHO Child Growth Standards median, and obesity is weight for height greater than 3 standard deviations above the WHO Child Growth Standards median. For children aged between 5 to 19 years of age, overweight is a BMI for age greater than 1 standard deviation above the WHO growth reference median, and obesity is greater than 2 standard deviations above the WHO growth reference median. Next is energy and its requirements. Energy is the ability to do work. The energy contained within the chemical constituents of food can be either trapped within the chemical constituents of the body or used to produce heat. It is defined property of chemical compounds and other physical systems. Carbohydrates, fat, proteins in the diet are responsible for its energy content and are made available to the body when these compounds are oxidized in the energy releasing reaction of respiration. Energy requirement. The energy requirement of an individual is the level of energy intake from food that will balance energy expenditure. The human body's total energy needs can be divided into 3 components as shown on the screen. They are energy required to maintain basal metabolism of the body, that is 60%, energy required for the muscle movements or physical activity 25 to 30%, and the energy that is released as the result of thermic effect of food, that is 5 to 10%. Next is units of energy. All forms of energy are interconvertible. The energy value of a food is expressed in kilocalories. 1 kilocalorie is defined as the amount of heat energy required to raise the temperature of 1 kg of water by 1 degree Celsius at normal atmospheric pressure. However, recently the International Union of Science and International Union of Nutritional Science IUNS has adopted joule as the unit of energy instead of kilocalorie. A joule is defined as the energy required to move 1 kg mass by 1 meter by force of 1 Newton acting on it. 1 kilocalorie is equal to 4.184 kilojoules. 1 kilojoules is equal to 0.239 kilocalories, and 1000 kilocalories is equal to 4184 kilojoules, and 1 millijoules is equal to 239 kilocalories. Next is energy value of food. The energy value of a food indicates its value to the body as a fuel. After a food is ingested, some of its energy may be lost during digestion and metabolism. Only 3 food classes releases energy, and they are carbohydrates, proteins and lipids. Carbohydrates gives 4 calories per gram, proteins 4 calories per gram and fat 9 per gram calories as shown on the screen. Determination of energy value of foods. The first system for giving energy values to the macronutrients was described by Dr. W.O. Atwater in the year 1899. The amount of energy released from foods and the amount of energy expended by an individual can be obtained by direct and indirect calorimetry. Direct calorimetry. The principle of direct calorimetry includes the chemical changes that occur when carbohydrates or fats are oxidized during respiration in the body. The amount of energy released or expended is measured by the heat produced. Indirect calorimetry. It includes when an organic substance is completely combusted either in calorimetry or in the human body, the oxygen consumed in amounts is directly related to the energy liberated as heat. Physiological fuel value. The amount of energy actually available to the body from a given amount of nutrient is called physiological fuel value. In the human body, the process of digestion does not proceed with 100% efficiency as carbohydrates, fats and proteins are not completely oxidized. Therefore, the entire amount of any ingested nutrient does not eventually become available to the body. The efficiency with which nutrient is digested must be taken into account. The coefficient of digestibility is used to express the proportion of an ingested nutrient and ultimately becomes available to the body cells. The coefficient of digestibility for carbohydrate, fat and protein are 0.98, 0.95 and 0.92 respectively. There is no loss in the metabolism of carbohydrate and fat, but in the case of protein, a part of energy is lost as urea due to incomplete oxidation. The loss has been estimated to be 1.3 kilocalories per gram of protein oxidized. The physiological energy values of carbohydrates, fats and proteins are 4, 9 and 4 respectively after making changes for the losses of food energy in digestion and metabolism. These values are called Atwater-Bryan factors or physiological fuel values. The next is recommended dietary allowances or RDA. RDA is defined as the average daily dietary intake level that is sufficient to meet the nutrient requirement of nearly all healthy individuals, that is 97 to 98% in a particular life stage and gender group. RDA is revised periodically by expert group of Indian Council of Medical Research ICMR and updated with newer concepts. RDA is based on Indian reference man and reference women. Reference man is aged between 20 to 39 years and weighs 60 kgs, free from diseases and physically fit for active work. Reference women is aged between 20 to 39 years and weighs 55 kgs. The latest RDA was revised in 2010 and recommendations for different age groups with nutrient requirements are shown on the screen. basal metabolic rate or BMR. The amount of energy required to carry on the involuntary work of the body is known as basal metabolic rate. It includes the functional activities of the various vital organs such as brain, heart, liver, kidney and lungs, and also the secretory activities of the glands, peristaltic movements of the gastrointestinal tract, oxidation occurring in resting tissues, maintenance of muscle tone and body temperature. Determinants of BMR. Many factors affect the BMR of an individual. They are as follows: body composition, gender. Males have higher muscle mass and lower body weight, therefore they have high BMR. Females have higher fat mass and thus have lower BMR. Next is age. BMR decreases with advancing age. Hereditary factors. Some people are born with faster metabolism and some with slower metabolism. Body surface area. Surface area depends on height and weight. Greater the surface area, higher the BMR and vice versa. Hormones. Some of the endocrine hormones like thyroid, catecholamine, adrenaline, growth hormone, all of this increases BMR. Pregnancy. BMR increases by 5% during the first and second trimesters. During the last trimester, it is increased by 12%. State of nutrition. BMR is lowered during starvation, malnutrition and wasting diseases. The next is body mass index or BMI. Body mass index is a measure of relative size based on the mass and height of an individual. BMI is defined as the ratio of weight in kgs to height square in meters of an individual as shown on the screen. BMI is used as a screening tool to indicate whether a person is underweight, overweight and obese or has a healthy weight for their height. BMR range. Raised BMI is a major risk factor for non-communicable diseases such as cardiovascular diseases, mainly heart disease and stroke, diabetes, musculoskeletal disorders, especially osteoarthritis, a highly disabling degenerative disease of the joints, cancers including endometrial, breast, ovarian, prostate, liver, gallbladder, kidney and colon cancers. Finally, conclusion. Food provides nutrients and plays a vital role in the maintenance of good health, prevention and treatment of diseases. Nutrients are the chemical compounds present in foods and are used to nourish the body and promote our health. Macronutrients constitute the bulk of the diet and are needed in large quantity and supply energy. Micronutrients are also essential in small quantities for the development of body tissues and other metabolic processes. Undernutrition can result from inadequate intake, malabsorption, infection or addiction to drugs and alcohol. Contrary, overnutrition results from overeating and insufficient exercise. Therefore, a well-balanced diet helps in obtaining all the daily required nutrients in desirable quantity to maintain health through healthy combination of foods from various food groups. Thank you.